Welcome to RSET Online. I am Dr. Asha Vishwanath, Assistant Professor in the Department of Civil Engineering, and I will be covering CE306 Computer Programming and Computational Techniques taken for S6 Civil. Now in this lecture I will be covering the Module 4, which deals with files and classes. Now, when large quantity of data has to be processed, we use files. Now, files are just like any other folder or files that you find in your computer. Now, why do we have files in a C++ program? Sometimes in a C++ program, you might not be able to enter large number of data as the input onto the console. In such a case, you have to enter the data into external file and save it as an Excel sheet or a text file, and then import that into your C++ program to be used into the program. In such a case, we use files. It can also be used when files are generated using some other softwares, and those files need to be imported into your program. Now, when files are created, it can be read into the program as well as written by the C++ program into the file. In such a case, the file will have two names, which are called the external file name and an internal file name. Now, the external file name is required by the operating system to be manipulated when the file is created, and the internal file name required when you read and write the data using a C++ program. The internal file name is also called a file pointer. Now, opening and closing a file. In a C++ program, we have to include certain header files for the file functions to be understood. The header file which we use is fstream.h, which has to be invoked in the start of the program. Now, there are three classes of input stream, output stream, and input-output stream. They are the if stream, which is used to open a file to read a stream of objects from the file, an off stream, which is used to write the stream of objects into the file, and an f stream, which is common for both reading and writing the stream of objects into the file. Now, the syntax of all the three are shown. For if stream, you write it along with the internal file name, which is infile in this case, and infile.open will open up whichever external file name you give into the parentheses. Here it is the data file. These two lines can also be written as a single file, like if stream infile parenthesis the external file name in double quotes. The same accounts for the off stream as well, as you can see. And the f stream, which is the common function for writing and reading, will include f stream, internal file name, parenthesis, external file name, comma, a mode. And this mode will instruct the f stream whether it is to be written or read or appended. Now, these modes are actually member functions which are written in the form IOS, double column, in, out, app, etc. Now we will see how we can read and write structured data types into a file. Now, as we have seen before, structures are user-defined data types. Now, these data types will include a structure name and internal elements into the structure. Now, we need special functions for reading and writing such data to files, and they are read and write with empty brackets. These are the functions which are used. As the name suggests, read is used again to get the data from the elements of the structure, which is generated in the C++ program, and write is used to write the data elements of the structure, which is generated by the C++ program, into a specified file. The syntax for reading and writing are as follows. The infile.read brackets char star and star comma the size of the string. Now here str stands for the structure name which I have given in my program. And char star, as you can see, it is a data type, actually a data pointer. Now char star refers to a pointer of data type char. Now char actually stands for the character variable of the structure name str. So char star and star, the first part of the first argument inside the parenthesis of infile.read stands for the pointer which points to which structure has to be written or read into my file. And the second argument inside parenthesis, size of star decides how much or the number of bytes which will be required to write the entire structure into a file. So these are the two parameters which you find inside the arguments, inside the brackets of the infile.read and infile.write. Now let us write a C++ program and see how all these that we have discussed are used. Now here we are going to write a program to prepare an input file which is containing the details of 30 students, roll number, name, age and mark of 3 subjects of each of these students. And this we are going to use in a structure. Now once the structure is created by the C++ program, it is written into an input file and we also calculate the rank list, that is based on their total marks, how they can be graded from the highest rank to the lowest rank. So we do also a sorting and we write it out into a file. From the file, we again use the C++ program to read it out and print it out from the file we have written. Let us see the program. Now this is the program which is on to the console. It is already executed. It is written out into the console, into the C++ compiler. As you can see, the usual header files are included, the iostream.h, fstream.h and the iomagic.h. The usual way of writing, as we have seen for structures, we declare the structure. Here the structure name is student and each student will include the roll name, age, 3 marks and a total. Now based on this total we are going to prepare the rank list. Now after that you can see that the fstream in file is also opened. Now just before asking onto the console how many records, you can see there is a line of fstream in file in which the file is opened. Now from the console we get all the data from the user inputs the roll number, name, age and marks, 3 marks, and the total is calculated by the C++ program as the marks are entered by the user. Now based on these marks there is a sorting taking place so that you can get the rank list. Now this, after the sorting is finished, you can see it is written into a data file .text file. So this is the external file name of that file, which is data file.txt, and it is used for writing, and hence you can see it is in file.open data file.txt ios : out. Now once we have opened that file, the way to write it, as we have seen before using the syntax, is infile.write. So write function is used, char star and data. Now here you can see that data is the structure. So and also an array. So you can see how each line of the array is written into the file using the write function. After that, we close the file. Once the file is written and closed, we again check out whether our writing has become correct. So for that purpose, we again open the data file.txt and write out this whatever is written into the file. We read it from the file and write out onto our console just to see whether the file is correctly written. So now we are again opening up the data file.txt, reading from it and writing out into the console. So that is what you can see in the last for loop, in which we are reading from the file. So infile.read is used. And in this case, we are using a different structure which is of the name rank, and we are using this rank to write out the complete structure which is sorted out into the console. Now once we run this program, we can see the output as follows. So as you can see, the user input is given, the how many records, enter data for all the 3 records. I have given 3 records here. And once all the 3 records are entered, it is written onto a file, and from that file we read it back onto the console, and we see the final 3 lines shows the information we have read out from a file, and that is the rank list. So this is how we can use a structure into our files. Now coming to another type of files, random access files. Now as we saw here, when we are doing the C++ program with files, we are writing it in a sequential manner. That is, from the beginning of the file and after each line we go on in a sequential manner. But what if we have to write into the file at some other point other than the beginning of the file? That is, we have to go to some other point in the file, maybe the end of file first, or somewhere in between the lines, to access certain data, that is to read or to write into that particular line of the file, already existing file. In those cases, they are called the random access files. In those cases, we need special functions to make our pointer, that is to use our get and the put pointer. We have used the get and the put functions before, right? So these get and put functions will be used, and they have to be told where to go in the file to be input, to be read or written. So for that case, we use the function seekg and seekp for writing in a non-sequential manner. Now they allow the random access and how they can be given, and as you can see, you can find seekg and seekp can be overloaded, which means that you can use the seekp and seekg with different arguments as well. That is, in one case, you can use it as seekg position and seekp position, where you will simply give the position of the file where you want the file to be read or written. In that case, all you have to do is give the position. Another way you can use seekg and seekp is by giving an offset or a direction. Both an offset and a direction, in which case you will tell it that go to the end of the file, or go to the beginning of the file, or go to the current position of the file. In that case, what you will be instructing the get or the put position is by giving an offset and also a direction in which to be written. Now the direction is going to be an enumerated data type which you are going to use just like you used iOS :beginning, iOS :current, and iOS :end. An offset is going to be how many positions from that line. That is, I want to write in the end of the file from the start position, or maybe 2 bytes away from the start of the end of the file. In that case, you also specify a number as an offset. Now, random access files, in the example you can see how it is used. It has the internal string positions with the get pointer and the put pointer, which you use to tell it where it has to go and write the particular file. You can see in the example, I have opened a binary file with the ifstream function. My file is simply the internal file name I've used. Example.bin is the binary file name, that is the external file name. And I use it tell G to get me the position where I want to begin writing. So I give a variable name begin is equal to my file.tlg, and my file.seekg will now be used with the offset and direction. Now offset is I want it to be written from the first position, that is the first cursor position, and the direction is going to be end of file. So I give it ios :end. Now another variable end is also used where I will tell G, that is I will tell it to go to the end of the file to find out that position. And once I close the file, I write down what is the size of the file, which will be just end minus the begin. Which are the file names which I use to find out where is my file starting writing and where is my file ending the writing. So that ends our files. Now we go on to the next topic, which is classes and objects. Now classes and objects are very important topic in C++ as it shows the object-oriented programming capabilities of the C++ programming language. Now objects is a modified form of structure. Now you can see, once you have seen the syntax which is written here, class box, you can see this looks very similar to a structure which we have learned. Just like struct, having a box as struct, you would still give the same variables inside the curly brackets and define it in the same way. Now we will see what are the differences between class and struct. Now class is just like a structure definition. It is a data type in which we define certain members in the class which will give some attributes of that particular object. So classes are written for objects. Now object is just a modified form of a structure. Now here you can see in the example I have got class as a data type which is defining the structure or the object box. Now I can call or refer this to my particular object called box1 in either of these ways. I can either write it as class box empty the brackets, and after that, along with that, write the object name and end it with a semicolon, or I can, after writing the class characteristics, write the line class box1. Just like we have seen this in structures. So classes, it is a central feature of C++ that, as I said, supports object-oriented programming. Now it is just another defined data type, and what is the difference that you will find between classes and structures is that classes can include both data as well as functions. Now the member variables, which are data, cannot contain an initializer, so you cannot use the specifiers like auto, extern and register that we have learned before. And also an empty class can also be declared as class with the empty brackets. Now there are 3 levels of protection for your variables or the member variables which you call, which are public, private and protected. This is just like the function that we have learned, the private and the public or the global function values, same property. Now private member variables are written inside a class with a keyword private, which means that they are not accessible outside the class and they can only be used inside the class. Now these can stand for both the data members as well as for the member functions. Now as I said, a class can include functions as well as data, unlike a structure. Now we will see an example after this. Protected, again it means that the data members will be protected and cannot be accessed outside, but it can be accessed by member functions inside the class and also by friend functions derived from this class. What these are, we will see later. Public members, as we usually say for global functions, we call it as global, just like global functions, they are accessed throughout the functions of any other within the scope of the class object, and it is open to the outside world. Now let us see an example of a class. Here you can see I have written class. Class name is my the name of the class that I have given. Inside you can see I have specified private, protected and public. Now there can be member variable declarations and function definitions under each of these specifiers, and the object names will be object name 1, object name 2 and so on. Now member functions, let us see an example. Now what do you mean by here? In this case I have written a class for an object circle. So circle is my object and I have written a class for it, and I have given a class name as round. So inside the class definition, I have given private variables and public variables. Now private, I have made the radius as a private variable, and public I have made the member functions. Now you can see the area and perimeter are the functions which we have specified inside the class definition. So this is an example of how you can define member functions and member data inside a class. So radius is a member data, area and perimeter are member functions. Now I have also declared and defined the functions. Here you can define the functions outside as well. We will see how later. Now member functions, as we said, it is, and how you can access these functions inside the int main after you write int main is through a dot operator, which is also called a period operator. Now let us see how it is done, and we'll go back and forth this page in the last. The first column, if you find class round, what we have written, the private variable is the radius, public member functions are area and perimeter, which are defined and declared inside the class definition. And I also have a read function, which is again written inside your class. And what it does is enter the radius, gets the radius from the user and takes in the radius value. So all this has to be written inside the class value because radius is a private variable. Now radius, once you come outside the class round, cannot be understood by any other functions. So you need to write that read function inside your class itself, because only then it can access your radius, which is a private variable. Now this way you can write the read the radius, find the area and perimeter, and then we start our C++ program with int main as usual, and then inside that we read circle.read. So that is the read function. So that means it will show, at that point it will show the enter radius, so the user has to enter the radius. The next point, you can access circle.area and circle.perimeter, where it will calculate area and perimeter and give out the output. So this same program, or this same bit of the program can be written in a different way by writing defining the area, perimeter and the read function outside your class, as in the second column. So as we said here, that the function prototypes will be inside, but you can define them inside or outside. And if it is defined outside, you use the double column operator, which is also called a scoping operator, to access them, just like you can see in the column 2. So the same program written in two different ways. Inside the int main, the program remains the same. Now there are two more things inside in a class which you need to understand, which is called a constructor and a destructor, which are special member functions. A constructor is a special member function again, which will have the same name as the class name, and it is defined with no return type, and it can take parameters, and it is also in the public visibility mode. Example. The same program, class round. So we have the round as the class name. Now the arrow shows the constructor. So inside the public, along with the member functions, I have declared also round function, which will invoke the enter radius. So instead of, it will do the same function as your int read. So what is the difference? Once you start int main, first it will run the constructor. If there is a constructor provided inside the class, first it will run the constructor. So first it will do, as soon as you start int main, it will do round. It will do the function round, which is enter radius. Now destructor is just the opposite of it. Once you have declared certain constructor, you can also destroy that place and eliminate that memory or space in the memory is released when the object goes out of existence, and that you write exactly the same way as a constructor, but starting with a tilde sign. So the tilde sign actually instructs the C++ program that this is a destructor which has to be destroyed. So the same program you can see with a constructor and a destructor. So what does a destructor do? It just simply eliminates all the information that a round or a constructor has invoked. Now friend functions, as we said sometime before, that private variables or private functions can only be accessed by friend functions. Now what are friend functions? Now friend functions are special non-member functions which can access the private members of your class. Now these friends will be a friend of the class, just like the name suggests. So only these friends can see, just like your the settings that you provide in your Facebook or the WhatsApp. You always see that the contacts can be friends and friends of friends. So what does that mean is it gives access only to the friend function. So that friend function has to be declared using a keyword friend. So you can see in the same function I have declared a friend int right round circle, in which here the round refers to the class name, circle is my object, int as usual is the data type of the function right, and it is a friend function, so I have put a friend in before the int right. Now friend functions can simply be invoked into the int main like your usual function call. Simply you write right circle and it will be called. But the property is that friend function can access radius, which cannot be accessed by any other functions that you write inside main. Friend classes are just another type of classes again which understand the private members of a class. One class and the other class can communicate being friends to each other. Now I will end this session by simply listing out the benefits of object-oriented programming. We have already seen that classes and objects give it a great property of being simple, that is, the complexity is reduced because the program structure is very clear using these classes and objects. Modularity, that is, it can be written out independently of the source. Information hiding, as we saw that different parts of the class are hidden, so the information is not simply roaming around and getting corrupted. Modifiability, that is easy to make minor changes by the data representation. Extensibility, that is you can always extend new features, plug in new classes into the program and extend it instead of writing the entire program differently. Reusable, that is you can use it in different programs by making it into different classes and objects. Maintainability, that is if any classes go corrupt, you can simply take it out and replace it by a new class or an object. The features of object-oriented programming are the same as we discussed now: the data abstraction, hiding, encapsulation, polymorphism and inheritance. Now abstraction, hiding and encapsulation are something what we discussed now. That abstraction, all data are abstract. You can use abstract data in your classes and objects. Hiding, by your protecting variable and the private variable that you use. Encapsulation is a combination or a package of both abstraction and data hiding process. Polymorphism, as we have seen function overloading properties before. You can also do the operator loading and dynamic binding. So we have already seen these topics of function overloading before. New thing that we are discussing here is inheritance. That is, one class can acquire the property of the other. I will simply speak one line about it. A parent base class and a child derived class. So just like the name suggests inheritance, which means that a class can inherit the properties of another class, and so the class which inherits becomes the child or the derived, and where it inherits from becomes the parent or the base. And there are different types of inheritance, like single, multiple, multi-level, hierarchical and hybrid, which we will see later on in the new lecture. Now, in these types of inheritance, as you can see, that when you inherit, what are the changes in the specifiers? That is, the public variables of the base class remains public, but becomes protected into a protected inheritance and becomes private into a private inheritance. So only public inheritance type of is commonly found, where all the member variables properties in the base class remains the same when they are inherited publicly. But when they are inherited into a protected way, the public becomes a protected. Public variables or member functions in your base class becomes protected into your new derived class. Same way, when the base class gets inherited into a private, all your functions, all your member functions and all the public, protected and private of the base class becomes private. So that ends my lecture. Thank you.